Start.
Hello students, in our previous classes we discussed about the energy and the types of energy. So we know that there are different forms of energy such like kinetic energy, potential energy, chemical energy, light energy, sound energy, mechanical energy. Such a way there are different types of energy. So today we are going to discuss about the kinetic energy and the derivation of the mathematical expression for the kinetic energy. So first of all, what is kinetic energy? So the energy possessed by an object due to its motion is called as kinetic energy. So generally when a body is in rest position, it acquires no energy. That means it possesses no energy. So the energy of a body which is at rest is zero. But when the body in motion, it possesses or it express some energy. That energy is called as kinetic energy. So the word kinetic is derived from a Greek word kinesis. So the word kinetic is derived from the Greek word kinesis. So in Greek, the meaning of kinesis is motion. That means when a body is in motion, it possesses some energy. That energy is called as kinetic energy. So the kinetic energy of a body is denoted by EK or KE. EK means energy, that is kinetic energy. So KE is nothing but kinetic energy. So the mathematical expression for the kinetic energy is KE, kinetic energy, is equals to half mv square or mv square by 2. In this expression, KE is nothing but kinetic energy, where m is mass of the object, v is velocity of the object. So why? Because when the body is in motion, it possesses the kinetic energy. So that's why kinetic energy of a body is depends on its mass and velocity. So from this expression we can understand that the kinetic energy of a body is depends on its mass and velocity. So kinetic energy of a body directly proportional to its mass and its velocity. That means if the mass of a body is high, it possesses high kinetic energy. If the velocity of a body is more, then it possesses more kinetic energy. So from this equation we can say that kinetic energy of a body is directly proportional to its mass, and also the kinetic energy of a body is directly proportional to its velocity. That means if the body has more mass, it acquires or it possesses more kinetic energy. If the body has less mass, it possesses less kinetic energy. As the same, if a body is moving with less velocity or less speed, it possesses less kinetic energy. If it is moving with high velocity, it possesses high or more kinetic energy. So what are the examples for the situations where the objects having the kinetic energy in our day-to-day life? So in our surroundings, we can observe different objects which having the kinetic energy. So suppose a fast moving cricket ball. So generally when the cricket ball is in our hand, it has no kinetic energy. Why? Because when it is in our hand, it is in rest position. So that's why it does not possess the kinetic energy. But when we are throwing the cricket ball, it possesses the kinetic energy. When the cricket ball with the kinetic energy hits the wickets, they will displaces from their position. As the same, a fast moving bullet. So generally we can handle the bullet in our pocket, but the same bullet when it is fired from a gun or revolver, we unable to or we not able to stand in front of it. Why? Because the moving bullet has the kinetic energy. So that kinetic energy of moving bullet causes some damage to us, right? Next, a fast moving stone can shatter the glass window panes. So generally, if you throw a stone towards a glass pane, that can shatter or that can broken down. Next, a fast moving saw blade. So generally in sawmills, the moving blade can cut the log of wood into pieces easily and fastly. As the same, the striker in the game of caroms also possesses the kinetic energy. Whenever you hit the coins by using the striker, due to the potential energy, kinetic energy of the striker, the coins will displaces from their position. As the same, a falling coconut, a speeding car, a rolling stone, a rotating fan, a flying aircraft, a flying bird, or a flying helicopter, flowing water, running accelerator, etc., etc. The objects all are having the kinetic energy. So here, when the coconut falling down, it possesses some kinetic energy. If the coconut falling on our head, we will have some damage. As the same, a speeding car. When the car is at rest, it does not possess any kinetic energy. But when the car comes into the motion with some speed, it possesses kinetic energy. As the same, a rolling stone. When the stone is rolling, it possesses the kinetic energy. So from these examples, we can say that when a body is at rest position, it possesses it does not possess any kinetic energy. But when the same object comes into the motion, it possesses the kinetic energy. So here kinetic energy is causes due to the motion of your body. So that's why the energy possessed by an object due to its motion is called as kinetic energy. So what are the units of kinetic energy? Already in our previous class we discussed about the units of energy. So what are the units of energy? Yes. So the units of energy in MKS or SI system is Joule. The units of energy in CGS system is air. So here the kinetic energy is also energy. So that's why the kinetic energy is also having the same units of energy. So that's why the SI or MKS units of kinetic energy is Joule. But we can express the same Joule as kg into meter square by second square. Why? Because if you write the mathematical expression for the kinetic energy, that is Ke is equal to half m square. Here the units of kinetic energy depends on the units of mass and velocity. So that's why if you write the units of mass and velocity, you can derive the units of kinetic energy. So here the units of mass in SI or MKS system is kg. The unit of mass in MKS or SI system is kg. As the same, here V for velocity. So that's why if you write the units of velocity in the same SI or MKS system, that is meter by second. But we have square to the velocity. So that's why here also we have to write square for the meter by second. Then it becomes kg into meter square by second square. So kg into meter square by second square is the another unit of kinetic energy in the SI or NK system. So here this kg into meter square by second square is also equals to 1 joule. So that's why the unit of kinetic energy in SI system or NK system is joule or kg into meter square by second square. As the same, the unit of kinetic energy in CGS system is air. Why? Because the energy having the unit in CGS system as air, but we can write the same air gas gram into centimeter square by second square. Why? Because according to the mathematical formula of kinetic energy, so kinetic energy is depending on mass and velocity. So if you take the CGS system, the unit of mass is gram. The unit of velocity is centimeter by second. So that's why we can write as centimeter by second square. Why? Because here v square is there. So gram into centimeter square by second square. So is the another unit of kinetic energy in CGS system. So the SI or NK's unit of kinetic energy is joule or kg into meter square by second square. The CGS unit of kinetic energy is air or gram into centimeter square by second square. Here the kinetic energy is a scalar quantity. That means it has only magnitude, but it has no direction. It has no direction. That means we can express the kinetic energy by using its magnitude only. We need not to write or specify the direction of kinetic energy, in which direction it is acting. So that's why kinetic energy is a scalar quantity. It has only magnitude, it has no direction.